Okay. Hello, everybody. Hope you are doing well. I'm recording this Thursday afternoon, so it's just now starting to get not so cold, but apparently we're supposed to get like maybe snow even. I'm pretty done with the cold temperatures. I'm sure a lot of you guys are as well. Looking forward to sunshine and time outside. So, I've got Lucy here. Where's your head? Okay. Um, since they decided to we're not going to have school anymore, I just went ahead and brought her back, and she's just going to stay with me for the summer, and I'll bring her back to school once we come back next year. So she's here. She's going through a shed, so she feels rough. So hopefully she'll cooperate. Okay, so we're going to go through a few slides of notes to um, talk about how energy moves throughout an ecosystem. An ecosystem, remember, is all of the living things in the environment as well as all the non-living things. So you look outside, it's everything that makes a place the way that it is, right? What makes northern Indiana different from Florida, different from Alaska, different from Mexico, different from whatever. They're different because of all those living and non-living factors, right? So we're focusing on energy, right? And ultimately, energy, no matter what, besides a few examples, comes from the sun, right? Some of this is pretty basic stuff. I'm sure you're familiar with a lot of these ideas, kind of grade school, but the application is more complicated. Okay, so it comes from the sun. Sun energy comes to Earth, and we have plants and some bacteria that photosynthesize, convert that energy into something that other organisms can eat, and then other organisms can eat those organisms, like Lucy here, and that's how we have life here on Earth, right? So, like I said, that's not actually true for every single ecosystem out there. Real quick, we talked about these a little bit, the deep sea vents that are really deep into the ocean. These giant plumes of what looks like smoke, but it's not. It's this dense, nutrient-rich grit that has all these different chemicals in it, and it's boiling hot. We didn't think anything could live down there, but there's actually thriving ecosystems down there. Now, again, this is over a mile below the surface. There is zero sunlight energy getting into the bottom of the ocean, not a single photon. And yet, life is able to live there. There's these giant, what are called tube worms. These things are like 10 feet long. There's hundreds of them here in this picture. There's fish, there's crabs, there's all kinds of different things. And the reason why they're there is because there's bacteria that have evolved something called chemosynthesis. Lucy is leaving. It's like photosynthesis, but instead of getting energy from the sun, they're getting energy from chemicals. What chemicals are they getting energy from? The stuff coming out of those big plumes. So it's not actually true for all ecosystems, but most ecosystems it's true. Even like caves. If you go deep into a cave could go maybe a mile out from the entrance, but there's animals coming out of that cave, eating things outside the cave, which thrives on the sun, and then they come back. So that cave ecosystem still thrives on energy from the sun. Okay, um, so all organisms, I think I've given these words before. I don't quite remember. You're either a producer or you're a consumer. Another word for this is a autotroph or a heterotroph. So producers produce. They get energy from non-living sources, chemicals like the bacteria and the deep sea vents. Plants, obviously, get energy from the sun. They're producers or an autotroph. Or you are a consumer, organisms that get energy from living or once living sources, also called heterotrophs. So Lucy is a consumer. She must consume other living organisms to stay alive. We are consumers. We must consume other organisms to stay alive. Even if you're vegetarian, you are eating other organisms to stay alive. So we are consumers. Further, you've probably heard of things like this. Again, this is pretty basic, but here it is for you. So you have it if you're not familiar with these words, but these are different categories of consumers. So there's scavengers, sometimes called detritivores, which is something that eats other already dead things, so like a vulture, right? Or sometimes crows or whatever. Omnivores eat both plants and animals, right? Carnivores eating only flesh, meat, like Lucy here, she only eats other living things. Herbivores only eating plants, and decomposers like fungus are decomposers, or worms are decomposers. But these are all different types of consumers, right? And sometimes you can go between these things. Like humans, one human might be a carnivore and eat no fruits and vegetables and nuts and so on, and another person might be totally herbivorous. Most people are on the spectrum of being omnivores, though, right? And even things like deer, white-tailed deer that we have around here, they are herbivores, but they also sometimes kill and eat animals, so technically they're um, omnivores. Right? So food chains. This assignment to finish up this week and then next week is all going to be about food chains and food webs, how energy moves throughout an ecosystem. So today's assignment is about food chains. Next week, I'm going to give you just one larger assignment on making your own food web. We'll talk about that in the future. So a food chain, like it sounds, again, I think you're familiar with the idea of a food chain, is what organism is eating what, sure, but what's better to think about is where the energy is flowing. So when you look at this food chain, you've got some grass, a grasshopper, frog, snake, and eagle. The arrows are, I don't want you to think of them as what organism eats what. It's where the energy is flowing. So you have energy flow, as the arrow shows, from the grass to the grasshopper, right? From the grasshopper to the frog, from the frog to the snake, and the snake to the eagle. That is the flow of energy. An interesting thing happens as that energy flows. It's not as simple as that gets energy from this, gets this, from this, and this, and it doesn't matter what level you're on. That's not true at all, okay? So it's a series of steps that shows how energy moves throughout an ecosystem, okay? And the arrow represents energy flow. So to communicate what organisms are on a food chain, we've got these different words here. And these you've maybe heard of, maybe you've not. So what level you are is called your trophic level. The word part troph or troph, T-R-O-P-H, basically means food, energy. So it's your food level, your energy level. And there's a bunch of these. There's pretty much 5. You can go more than 5, but you rarely get more than 5, as we'll discuss why getting into next week. Primary producer. Really, you can just call it producer. There's no such thing as a secondary producer, but a producer. So that's like a plant. Then if you're the first consumer to bat, so to speak, you're the primary consumer. You're the first one. If you eat a primary consumer, you're called a secondary consumer. Secondary consumers get eaten by tertiary consumers. Tertiary consumers get eaten by quaternary consumers. Tertiary means 3, right? Primary 1, secondary 2, tertiary 3. Quat means 4. Think like quarter. So over here in this example, the grass would be a primary producer or just a producer. The grasshopper would be a primary consumer because it's the first consumer. The frog would be a secondary. Snake would be a tertiary. The eagle would be a quaternary, and so on. And you can further describe it as like the snake is a tertiary carnivorous consumer. Or you could say the grasshopper is a primary herbivorous consumer, and so on. So I've got a few questions looking at this example. So here's the food chain that has some questions about it. The questions are on Canvas, so I want you to go there. I think there's 5 of them. I want you to answer those. Next week, we're going to talk about what happens to that energy as it flows throughout an ecosystem. It's not as simple as just this to this to that. Some interesting things happen there, and we're going to talk about that and get into food webs. Okay? Alrighty. Probably got to give Lucy a bath because she's having problems with this shed. I'm going to stop here, and there.